Hello, we are here learning 10.4 today, and our focus today are going to be inverses. So you have already evaluated trig functions when you're given the angle, but you can also find the measure of the angles given by using the inverse. You actually did some of this in geometry. So whenever you are trying to find an angle measure, that is when you would use the inverse. Okay, so you can find the measure of the angles using the inverse trig functions here. So this is the symbol for an inverse. You'll see that -1 superscript here kind of looks like an exponent. That is the notation. Just a few things about inverses. So this expression here, that's read as the inverse sign. It's the -1 that shows you that this is the inverse. This part isn't in your notes, it's just something we're going over. But don't get that confused with the reciprocal. So remember, the reciprocal of sine would be 1 over the sine, or the cosecant. The inverse has the -1. Or if you're saying, oh, it's the opposite. Well, the opposite is the sign on the outside. So sometimes people misuse these three terms. So I just wanted to write out for you what the inverse is, what the reciprocal was, what the opposites were. So this is your term for the inverse. Now this question asks, why aren't inverse functions functions themselves? So we're going to talk about that real quick. So the inverses of trig functions are not functions themselves because there are many values of theta, okay, for a particular value of a. So if you want to find the inverse of the cosine inverse of 1/2, well, there are two places on the unit circle that would give you an x coordinate that's 1/2. So for the input, there's actually more than one output. So that's why the inverse functions are not functions themselves. So for inverses, the input can have more than one output. And therefore is not a function. Okay, because if it is a function, for every input there is at least one output, or there is one output. So you can't have multiple outputs for one input. When you plug something in, you'll get one thing out. All right, for our first example, we are going to find, this says all possible values of the cosine inverse of √3/2. So what we're going to do is we're going to use our unit circle. We're going to find the values first between 0 and 2 pi. Whenever you see this, the 0 and 2 pi, that just means one time around the unit circle. Okay, so 0 to 2 pi is one time around the unit circle. For which the cosine value, which remember the cosine value means the x coordinate, is equal to √3/2. So for this, you guys can just use the unit circle that you made. You're just going to look for all of your x values where you have the √3/2. Okay, so √3/2, positive value, happens at pi/6. And then you want to find the other value, which is here at 11 pi/6. Okay, so step 1 would be pi/6, okay, and 11 pi/6. So those are the places where your x coordinate is √3/2. All right, in step 2, it says find the angles that are coterminal with the angles measuring pi/6 and 11 pi/6 radians. So coterminal means you can do any type of rotation, okay? So looking at this, we saw pi over 6 and 11 pi over 6 is where you have the x-coordinate is root 3 over 2. When it's asking for the coterminals, that means if you were to go around the circle, every time you hit that point, that would be an angle, right? So because you're going around 2 pi, what you end up doing is you end up adding 2 pi times n. So you're going to add integer multiples of 2 pi, and this is where n is an integer. So the way that you write your final answer is going to be pi over 6 plus 2 pi n. So that's one of your answers. And then the other answer is 11 pi over 6 plus 2 pi n. Okay, and that is where n is any integer. All right, so when you have the n value, that means if you plugged in 1, okay? When you have pi over 6, if you were to add 2 pi once, you would be here, okay? If you add plus 2 pi, this would be 12 pi over 6, so you'd be at 13 pi over 6, okay? That includes that point. Then you could add 2 pi again, and that would keep continuing, okay? Same thing here. You could add 2 pi, and then you keep adding 2 pi. So the n is to account for multiple times where you're rotating around the circle. So n, it can just be any integer. So if you plugged in 1, you'd go around twice. If you plugged in 2, did I say twice? If you plugged in 1, you go around once. If you plug in 2, you go around twice. If you plugged in -1, you could go around the negative way. So whenever it says find all the possible values, you want the 2 pi n because there are an infinite amount of times that you could rotate around your unit circle. Okay, so for B, you're finding the tan inverse of negative root 3. Now, you don't have the tangents written on the unit circle, but remember how I showed you that you could memorize each one? So we know here at pi over 3 that your tangent is going to be root 3. So any place here where you have a negative, we can use all students take classes. So everything's positive here. Students take classes. Tangent is positive in quadrant 3. So you want to find the place where tangent is negative, and that's in quadrant 2 and in quadrant 4. So if you know that this is root 3, then the reflection here would be negative root 3, and the reflection here, oh sorry, this is positive root 3 for tangent, is positive root 3, and then this is negative root 3. So we just have to find those places on the unit circle. So this happened at pi over 3. You use your unit circle. If you do the reflection, this is going to be at 5 pi over 3. And then if you do this reflection here, this is at 2 pi over 3. Okay, so then we're going to write our final answers as 2 pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. Okay, so really for these, all you're doing is finding where the tangent is this value and then adding 2 pi n. Okay? And for most of these, there are going to be 2 places. Of course, there are some special places where you might have 1, but that would be something where you're looking for a value that's 1. So like the cosine is only 1 here. There's no other place where the cosine is 1. That's just an example of a special one. Okay, now, because the inverse functions are not functions themselves, we do have limits that we can place on them. So in step 2, we're going to talk about these restricted domains. Okay, so in this textbook, they're indicated with a capital letter. So if you see the capital sign, capital cosine, and capital tangent, that means that you have a restricted domain. The way that these are written, I'm going to show you here, looks like this. So the sine of theta, it's the same as the sine of theta for, and I'm just going to show you this part here. So this is your set builder notation. When you see this, it's theta such that theta is in between negative pi over 2 and pi over 2. That's what that means. Okay, so it's theta such that theta is between negative pi over 2 and pi over 2. Okay, so let's think about what that means on our unit circle. So if this is pi over 2 and this is negative pi over 2, what this is saying is theta has to be somewhere in between those. So that's going to cover quadrants 1 and 4. Okay, so for the sine, the restriction is in 1 and 4. These are based on where the function is 1-to-1. So a place where you can only get one output for the input. And because these sine and cosine, because these are different places, you're going to have different restrictions. We are going to study their graphs, and this is really easy to show you on the graphs. We just don't need to get into all that right now. I don't want to overwhelm you, but these do come from somewhere. So the cosine is restricted between 0 and pi. So again, when you're reading this, think of it as, oh, I know that 0's here, I know that pi is here, so that means these are restricted to quadrants 1 and 2. And then for the tangent has the same restrictions as the sine. And again, this is based on their graphs. This is based on where they are 1-to-1 on the graph. The only difference is here you'll notice that we just have less than symbols, and that's because the tangent values at negative pi over 2 and pi over 2 are undefined, and that is why they are not included. Okay, so if we're going from pi over 2 to negative pi over 2, we are still looking at quadrants 1 and 4. Okay, so the restrictions for sine 1 and 4, cosine 1 and 2, tangent 1 and 4. And those are indicated with a capital letter. On your second page, it does have all of this laid out in your chart. So the inverse here, here's your symbol. They tell you what the domain is, so values that you can plug in. And then here's your range in radians and in degrees. Okay, here's your range again in radians and degrees. Okay, so again, the range, this is Q1 and 4. This is Q1 and 2. This is Q1 and 4. Okay, so for example 2, it says evaluate each inverse trig function. Give your answer in both radians and degrees. Notice it doesn't say all, so we don't have to do the 2 pi n like we did before. Another thing you might notice here is these are also called, besides the inverse, sometimes you might hear them referred to as the arc sign. That's another way to say the inverse, the arc cosine, and then the arc tangent. Okay, so for this, again, you have the capital. So what we're going to do is we're just going to find the value of theta. So you're going to find where on the unit circle in quadrants 1 and 2. So where in quadrants 1 or 2 is the x coordinate negative root 3 over 2. I hope this video is not going to have any lapses in it. I did do a test, but I think sometimes my screen goes black, so I wonder if that's what did it. We will find out. All right, so this is what you're thinking to yourself. Where in quadrant 1 or 2 is the x coordinate negative root 3 over 2? And again, you can just use your unit circle, but hopefully we remember the cosine is going to be negative in quadrant 2. So this occurs at 5 pi over 6, which is 150 degrees. And that is all you need for your solution. Okay, so just based on where it is 5 pi over 6. We don't need to add the 2 pi n because it didn't say find all of them. And that's 150 degrees. And then that's all you have to do. Okay, so for the sine, the capital here, so what you're asking yourself is where in quadrant 1 or 4 is the y coordinate 3 over 2. Okay, so then for this one, if you are looking on your unit circle, you have root 3 over 2, but you don't, or sorry, we're looking for the y coordinate. You have root 3 over 2, but that's not 3 over 2. Okay, so if this happened, if it's not on the unit circle, what you would want to do is use your calculator. Okay, so you can use your calculator to evaluate. Now, something is going to happen here, and you may or may not have noticed this, but we'll go back if you didn't. So we'll do second and then sine inverse. And it's okay that it's not capitalized. And then we're going to go 3 over 2. Okay, now it says there's a domain error. So let's go back up to where we were talking about the domain. Remember, for the sine, you can only plug in values that are between negative 1 and 1. 3 over 2 is greater than 1, which means it is not in the domain. Okay, so what we would say is that this is undefined. Okay, since 3 over 2 is greater than 1, it is not in the domain. Okay, and then we would say the sine of 3 over 2 is undefined. Okay, so if you get an error, it is undefined there. Okay, and then let's say that you didn't have a value that was undefined. We'll do sine inverse. We'll just do like 3/4 real quick. Okay, let's say you got that. Go to your mode, and then you can see my mode is in radians. So you could just leave it as 0.84 radians, no pi, or you could change your mode to degree. And then you could do the same thing where you do your sine inverse, and then it's 48.6 degrees. You could either just use your calculator to find both of them, or if you wanted to take this and multiply by the conversion, which if this is your degree would be pi over 180, you could do that as well. Okay. All right, and the last one is the tangent. So you're asking yourself, where in quadrant 1 or 4 is the tangent root 3 over 3? So where in quadrant 1 or 4 is the tangent, and by tangent, remember we mean y divided by x, root 3 over 3. And so I like to go back to this. Remember I told you how to know which one is which. It's root 3 over 3 and then 1 and then root 3. This is the positive, and that occurs at pi over 6, which is 30 degrees. Okay, that is the first part of 10.4. So we are going to stop it there. And then there will be a part 2.